Hello everyone, today we would be going through another video on software, specifically controlling motors. To give an overview on the topic, we would be studying about three motors, namely the Talon SRX, the Victor SPX, and the Falcon 500. To install, we would copy this link. Now we would look at the VS Code. We would click on this icon, manage vendor libraries, install new libraries online, and paste the link. To make sure you've installed it, we can look under vendor deps and see phoenix.json. So now to discuss about the motors in detail, we will look at the various methods which would assist us in coding a successful drivetrain. I hope that this slide would help you in gaining an understanding of how to use them. First off, we import these libraries. Next, we make a field variable. An important point to remember is that if the motor is inverted, meaning it spins in the opposite of the intended direction, we would write this code. To make the motor move, we would use this method where -1 means backwards and 1 means forwards. To create a Victor SPX or Falcon 500, we would replace Talon with those names, respectively. Are you interested in knowing how a self-driving car keeps the car on the road and drives it to its destination? So basically, an important concept in control theory is PID, which stands for Proportional Integral Derivative Control. Do not worry, even though you need a bit of calculus to understand it, because you can visit this website, which would provide a great introduction to it. In addition, the modes which implement PID are control mode of position and velocity, which take a number from -1023 to +1023. However, if you want to do it manually, you select a p-value and then experiment with it. In order to make sense of the position mode, let's consider an elevator which needs to go to the 5th floor, using the ground floor as a reference point. First off, we need to find the ticks, set the initial velocity, and then set the motor. Similarly, to get a sense of velocity, we first set the feed-forward term. Then we convert the RPM to ticks per 100 milliseconds. Additionally, we use config and set and get methods of the motor to get the desired speed. Next, I will be touching on a coding example of how to drive the robot. So there are 8 cases which we need to consider. Let's look at left first. So for left, the right-hand side goes forward while the left-hand side goes backward. This causes the robot to spin in the left direction. The same thing for right, except the forces are flipped. For the forward, both forces point in the forward direction. For backward, both forces point backward. Left and forward is an interesting case. To go forward, both forces need to point in the forward direction. However, to go left, the right-hand side needs to spin at a faster rate than the left-hand side, causing the robot to spin towards the left. Left and backward is another interesting case. To go backward, the forces need to point backward. However, the robot's left is not the same thing as our left. The robot's left would be our right when going backward. That's why this force would be faster than this one. Right and forward is the same thing, except the left-hand side needs to go at a faster speed. Right and backward is the same as left and backward, except the right-hand side spins faster. So let's look into VS Code. Let's say the left-hand side has 2 Talon SRX, the right-hand side has 2 Victor SPX. Furthermore, let's say that the left-hand side is inverted. So we can do Furthermore, we need to say that the current location is the 0th location, so we can use it as a reference point. So we can do okay, so that's for robot init. Now let's go to autonomous periodic. Let's say in the autonomous periodic, we want to go 2000 ticks forward. So what we can do is first we need to set the PID constants. So for P, let's say we want to go at half speed. So what we can do is with slot index, so just say it's 0. Like we won't use multiple PID constants, so we can just say it's 0. And then we can do half of 1023 divided by the desired position, which is 2000. We can do the same thing for the other ones. So now that we have set the P constant, we need to set the I constant. So for I is 100th of the P constant. So we can just copy this and say finally D would be 10 times the P constant. So we can do, so that's for setting the PID constant, and then finally we can make it go to the 2000. We can make it go forward 2000 ticks. Okay. Now we can go to teleop periodic. In teleop periodic, the user controls the robot using joysticks. So first we need to create an OI class. So we'll create a joystick instance. And then we'll go to teleop periodic. And then first we need to create an instance of the OI class. So we'll go all the way to the top. And then so we can first we get the how much forward the user wants to go. So this method returns a number from -1 to 1, and then double turn would be for how much the user wants to go in the how much the user wants to turn left to right. And then so for to set the left hand side motor, we can do forward times 0.7 and add it with the turn. So we want to make sure the max is 1. So that's why we multiplied it by 0.7 and 0.3. For the right hand side, we would subtract. And this was explained in the. So now all we need to do is just set the motors. Okay, so that's it for the coding. Thank you.